Good evening and welcome to the first event at the NASA at My Library program. I'm a founding member of Astronomy for Change, whose mission is to elevate society through positive change, specifically using astronomy, science generally, and astronomy specifically. Okay, what we're going to do, we have a multi-part program tonight. We're going to have a quick 30-minute presentation of an astounding discovery only back in August, followed by, if the weather remains clear, an observing session using the library's telescopes. We're going to be looking at the moon. It's one day past full moon. Last night we had a supermoon. A supermoon is simply the moon in its perigee at the full moon phase. So it appears a little bit bigger. That's why they call it a supermoon. And then, hopefully, if it remains clear, we have Orion. There's a lot of very interesting objects that we can see that are just starting to make their way into the sky now as the seasons change. Okay, also as part of tonight's program, in case you don't have a copy, I printed a copy of a primer. That basically describes what we're going to be talking about tonight. Since we only have a limited amount of time, this is going to be a 30-minute discussion. I'm going to try to make it as family-friendly as possible in terms of not too high, not too low, but we're going to try to give you a sense of the discovery that was just made, just back in August. Actually, it was published in October. Okay, so who's seen Star Wars? People my generation have seen Star Wars. How about the little ones in the audience? Have you guys seen Star Wars? Does that look familiar to you? A long time ago in a galaxy far, far away? Who doesn't know what a galaxy is? Everybody know what a galaxy is? The Milky Way galaxy is what? About 200 billion stars all together in the universe, in which we live, all bound together. Okay, that's a galaxy. There are 100 billion of them in the universe, and each one of them has 100 billion stars. So there are more stars in the universe than there are grains of sand on our planet. Okay, so what happened in this particular galaxy, which you can see right there, this circular object here, that's a circular galaxy. Right here in this little box, you see a star, what appears to be a star, basically brightening and then fading. Okay, and that's the topic of tonight's discussion. But before we get to that, we have to tell you basically how we got here. Okay, and that's what, if you take a look at that flyer, at least for the moms and dads and the adults, you can kind of get a sense of what it means. But I'll do my best to explain the whole thing. Okay. A very smart man named Albert Einstein, he was famous, he came up with this idea called relativity. He said, well, he worked in the Swiss Patent Office in 1905. He was looking out the window and he said to himself, what would happen if I could ride on a beam of light? What would I see? What would the world around me look like? Okay, and from that point forward started this idea of relativity, or what would work out to be things are not, there's no absolutes. Everything is all relative, including time and space, as we're going to come to see. So what we're going to talk about tonight is a discovery that shook the world, and that's called gravity waves. Now, gravity waves is not something you can go to the beach, go swimming in. What are they? It's kind of weird. Probably people never really heard of this before, right? What are gravity waves? On October 3rd of this year, 3 people from this country won the Nobel Prize in Physics, which is for you young ones in the audience, a very, very prestigious award given to very, very smart people. Okay? And what these 3 people did, they discovered something that shook the world. Okay? For very decisive contributions to this machine that allowed us to measure some changes in the Earth's surface that are so small, they're 10,000 times smaller than the width of an atom. That's how gentle a change it was. Okay? Okay, what happens is, you see this little red light here? Everybody see the red dot on the screen? That's what we call a laser. Now, if I take two of these and shine them, one facing this way and one facing this way, and if I move one, it moves compared to the other one, right? Well, think of something so small that you couldn't even, it's hard to describe, but imagine chopping that dot up 1,000,000 times. And then this machine could detect changes that are 1,000,000 times smaller than that. Okay, so that's what happened back in August. Okay, this is what they look like. It's in the state of Washington, one's in the state of Louisiana, and one is over in Italy, okay, near the town of Pisa. Okay, so who's heard of Isaac Newton? Even you young boys and girls have heard of Isaac Newton, right? Isaac Newton, he basically put forth the idea of a clockwork universe, that everything's predictable, organized, and follows a very precise set of rules. Okay, and give it enough time, you can compute anything and figure everything out about the universe. Okay? If I took something and held it up and dropped it, it would fall to the floor. And we know how to do that. We've done it since 1687, since when he first discovered this idea, right? So that's the how of the motion. That's motion. When you drop something, it falls. That's a motion. That's how we can do some math, and we can figure out how fast it's falling, how long it's going to take to get there, and all that. That's the how. Einstein came along and figured out the why. Why does that happen? Okay? Einstein said there are no absolutes. Okay, space, time, matter, and energy are all relative. Okay, going back to this idea of Einstein riding on a beam of light, the faster you go, time slows down. That might sound like a crazy idea, but it really does. We've measured this in experiments. Many experiments since in the last 100 years since Einstein first came up with this idea. Okay? Everybody kind of following along with me? Yeah, that primer should help. That's why I... Okay. Rather than think of gravity as a force that's pulling something to the floor, think of it more like a fabric where you have space and time are all connected. Who's seen Star Trek? Star Trek, have you seen Star Trek? You've seen Star Trek. Captain Kirk and the Enterprise. That could be all real, you know. That's all based on Einstein's ideas. And that Starship Enterprise really can basically travel through space. That's what Einstein said. Okay? And that's the basis of what we want to get to tonight. That's the starting point. That's the background for this discovery I'm about to tell you about. Okay. If we take the Earth and the Moon, and we imagine we have this gigantic rubber sheet, we put the planet and the Moon, what's going to happen? The bigger it is, the more stuff the planet has, the more it's going to put a dent in that sheet, right? The less of stuff it has, it's going to be a lesser dent. What happens if I start that Moon going around the Earth? What's going to happen to the dent? Anybody can tell me what's going to happen to the dent? The dent's going to travel with it, right? This is what Einstein said, and that creates a gravity wave. That dent, as the Moon goes around the Earth, creates a wave. The heavier the Moon is, the bigger it is, the bigger that wave. An object that's really, really super heavy, what's going to do, instead of just putting a dent in the fabric, it's going to tear a hole in it. And just like the Starship Enterprise, you're going to travel through that wormhole to another part of the universe. This is all based on Einstein's ideas, and it really does work. Okay? If it's really heavy and it rips the fabric, it's called a black hole, where nothing can come out from. You can't communicate into it. You can't get any information out of it. It's just empty. You can't get into it and can't get out. If you saw the movie Interstellar, Interstellar was actually pretty good. And one of the consultants who went into writing the screenplay for Interstellar, Kip Thorne, was one of the Nobel laureates who received this prize back in October for this.
About the black hole with time travel?
Yes, and it is possible. There's nothing in physics that says we have to keep going forward in time. It is possible to go backwards in time. Yeah. Yes, that's what that is. You can. You go right through that funnel right there, and you come out the other side, you're in another part of the universe. Isn't that cool? That is really cool. I don't know if I'd want to go.
Did they figure out how deep that
A black hole can suck up anything, and it could crush it with anything.
Wow.
Gravity is very strong.
Yes, where did you learn that?
From my dad.
That's fabulous. That's fantastic that you know that. What do you want to be when you grow up? Do you want to be a scientist or someone who studies math? Good for you. Good. Awesome. Okay. Okay, any change, any disturbance in that fabric, that would include something in orbit around something else, or two big heavy things colliding and coming together. Okay, that will cause these gravity waves to basically travel. The word is propagate. They travel at the speed of light. So this laser beam, that red dot, travels at the speed of light. So do the gravity waves. This is what Einstein said. Okay? So in a galaxy far, far away, a long time ago, 135 million years ago, when did the dinosaurs kind of just go away? Who knows the answer to that? You know that? They went, well, it's a couple of things. The big one is an asteroid hit the Earth 66 million years ago, kind of started them all down this path that they couldn't come back from, right? Well, that's 60 million years after this. 135 million years ago was at the peak of the age of the dinosaurs, is when this merger happened that caused the gravity wave, which is what we're getting to. Created a nova, they call it a KiloNova, and it's a huge explosion, and astronomers were able to observe this and confirm for the first time, not infer by some other method, but actually observe the result of this merger in the form of a star that, it's not a star, but in the form of a very powerful explosion. Okay? 135 million years ago, at the peak of the age of the dinosaurs, two neutron stars locked together in this very tight orbit in what we could call a death spiral, eventually came together and merged. And when they merged, tremendous amount of energy was released. Okay? And let's take a look at what it might have looked like. Now, those blue spirals, those are the gravity waves. And there's the explosion. Two seconds after that happened, one of our satellites in orbit, which looks for these things called gamma rays. Who's gone to the dentist and had an X-ray done? You have. It's not fun, is it?
No, it hurts.
Yeah, it hurts. I know. Everybody's been to the dentist and got an X-ray. Well, X-rays are almost as powerful as gamma rays. What astronomers have in orbit around the Earth is a satellite that looks for gamma rays. Gamma rays are only produced from stars that explode. Okay, 2 seconds after they received the gravity wave signal at these detectors that could measure changes 10,000 times smaller than an atom, they saw a gamma ray burst in the sky, and they trained their telescopes in that direction, and they could see the light fading from this huge stellar explosion when two neutron stars came together. Now, you're probably wondering, what is a neutron star? Okay, a neutron star is the end result of a very, very big star that has used up all its fuel, which is hydrogen. Stars shine by taking hydrogen and producing helium. Who's ever been to the circus and you get a helium balloon? Helium was actually first observed on the sun. That's why we call it helium. Helios is the sun god, right? So stars like our sun, it takes hydrogen. You've heard of this thing called hydrogen. Who knows what water is? Hydrogen, two hydrogens, and an oxygen make up water, right? Right, so hydrogen comes together inside the sun, makes helium, and produces a lot of energy. But the sun doesn't have an infinite amount of hydrogen, so what does it have to do? When the hydrogen runs out, it starts to use the helium, and that makes oxygen and carbon. Everybody goes to school. Who uses a pen, who uses a pencil? You use a pencil or a pen? If you use a pencil, that carbon inside that pencil was produced inside of a star. The oxygen we're breathing here today was produced inside of a star. In fact, all the stuff that makes up our bodies was produced inside of a star. The reason our blood is red is from the hemoglobin, which has that iron as a basis. That iron was produced inside of a star. Star is so big that when they get to the point where they can't make any more energy, they explode in what we call a supernova. And sometimes, instead of completely destroying itself, what's left over is a neutron star. Well, in that galaxy, two of them were in orbit around each other. Two stars had exploded a long time ago, and the remnant from those stars, the neutron stars, were in orbit, and because of the tremendous gravity, they came together and they merged. And that merger produced this tremendous explosion. Okay, and that's what I said, right? The star can either continue on existing as a neutron star or continue along another path and become what we call a black hole, right? Either one. In this case, they remained as neutron stars. Okay, where was it in the sky? How did we know? How did we know where to look? Well, there were 3 of these detectors in operation that night. One up in Washington State, one in the state of Louisiana, and one near the town of Pisa in Italy. And they were able to use the positions from those 3 detectors and what they call triangulate on the sky. Triangulate is when you have 3 points of information and you can use a triangle to figure out where it came from. And that yellow band right there on the right side of this ball, right here, is where this exploding merger was, okay? In the constellation of Hydra. We can see Hydra, it's nothing to see, but that's where it was in the sky, okay? The merger resulted in the stellar explosion known as a KiloNova. It's about 1,000 times more powerful than a regular nova, but not quite as powerful as what we call a supernova, which in most cases just completely destroys the star, okay? That term was introduced 7 years ago in 2010 for precisely this purpose, to describe these events that there was no descriptor for. Okay? And this is what the light looked like. If you take a look up here, that's the number of days since they found it. That's the light level. That's the brightness of that nova over time. That's 4 days. 5 days. Eventually fades out to basically the flat line. Now the blue over here, this large peak over here, that's for, remember I told you stars produce like helium and carbon and oxygen? Well, what about stuff like things heavier than iron and gold and platinum and uranium? What about all those? Those aren't produced in the supernova because the supernova can't make them because they're so heavy. They're made in places like this. Okay? So that blue peak over there is for the lighter elements, and as it fades over time, those are for the more heavy elements. Okay? Okay, and some of the things that were made, gold and platinum, right up there, gold and platinum, okay? And all these other very odd elements that you don't really hear too much about, but every element, for the boys and girls in the audience today, someday in school you might study chemistry and physics. And if you do, you're going to learn about the periodic table of the elements. All of those elements in that table were produced inside of stars. And things like gold and platinum were made in mergers of 2 neutron stars, just like this. Okay? And what's so spectacular about this, we observed back in September of 2015, we observed gravity waves. We detected them. But this visible observation, this is the first one. And because of all everybody working together as a team, see what happens when you work in a team? Good things happen when you work in teams, right? Okay, so working as a team with these satellites in orbit, we were able to pinpoint the location on the sky, and all our very powerful telescopes were then pointed at that spot on the sky, and we took all these amazing pictures and gave us all this tremendous, there's already been almost 100 scientific papers published on this, and this just happened back in August. So this is quite a tremendous thing. Okay, that's the table of the elements. Okay, up here, there's hydrogen and helium. For the younger ones in the audience, this is what the world and the universe are made of. These is the building blocks of the world and the universe. Okay? It's impossible to overstate the importance of this, and I suspect that much of this will lead to Nobel Prizes. Okay? And these are the various pictures from various telescopes operated by the European Southern Observatory. Now, this was a combined effort between the Europeans and the Americans. NASA had the Hubble Space Telescope, we had the Fermi Gamma Ray Observatory, and the ESO, the European Space Organization, had some very powerful telescopes in South America, in Chile, way up high on the top of a desert plateau. Okay, looking at this. So it was a combined effort. Okay? And, well, if you study science, you're going to learn about Isaac Newton. That's where you have to start. Learn about Newton and how the world works. And then you can start learning about Einstein. Because what Einstein gave us is a gift that keeps on giving. Anybody have any questions? Yes?
How is gravity so powerful that it could crush anything?
How is gravity so powerful that it could crush everything? Because I guess you're talking about a black hole, right? Okay, think of how, you know how huge the sun is? Okay, the sun is really, really big. It's a lot bigger than the Earth, right? So what if I took the sun and compressed it down to something the size of a basketball? What do you think would happen to all this stuff? With all the gravity? It would be really incredibly powerful, right? But a black hole keeps on going to where there's nothing, not even a point. So the gravity becomes almost infinite. Infinite means never ending, keeps on going. Even like this microphone has a tiny amount of gravity. Something really big like the Earth or the Moon and the Sun and other stars have gravity, and the amount of gravity they have depends on how big they are and how much stuff they have, really. But a black hole is something very, very special. And think of the entire star crushed down to something the size of a pinhead, and that would be a black hole. It's really enormous. Anybody else? Okay, I just want to also mention, I'm one of the founding members of Astronomy for Change. I mentioned this earlier. If you go to astronomyforchange.org, you can read all about us. You can become a member. It's free. You can get our newsletters. You get to learn about events like this. And you can become part of something that's really big and growing. Astronomyforchange.org. Okay, great. Thank you. Thank you. Thanks.